So now that we know how to use and access or paint attributes, let's use this knowledge to build this kind of animation here. For that, I'm going into my setup, which is like this. So I painted an attribute onto my grid here, which I then use to scatter those spheres onto it. And this attribute here is called density. And what I want to do in the end is use the spheres that we scattered onto this grid using some sort of noise. And the most straightforward, easiest way of doing that would be to use a mountain sub, which will wire in after the density attribute. And the mountain sub just distorts your geometry, like so. And I can use those parameters here to dial in the noise that is used to distort the grid, maybe something like that. So if I want to limit this distortion to the areas where we just painted the density value in here, I could use the group attribute up here, the group field. And usually that's used to just type in a group's name, and then the effect of this node, in this case the mountain node, is limited to said group. However, in here we can also type in short expressions. So I want to check if my density attribute that I painted is above 0, so if it's bigger than 0. And we do that by typing in an at to access an attribute that's on this geometry stream that's piped into the mountain sub. Then the attribute's name, density. And now we want to check if it's bigger than 0.0. And if it is so, we apply this distortion here. So let's use that to then scatter points on it, and again use it as a geo to relax the points onto. And then when we highlight the out node here, we can see this is what we're getting. So if I want to animate this now, I'm running into a few issues. Let me demonstrate. Let's animate this using the Y offset, and either you could keyframe this by shift-clicking in here, which would open up the keyframe timeline, and then alt-clicking in here, setting one keyframe at the current frame, then moving this to the end of the animation, setting this value to maybe 2, alt-clicking in here again, and then I'm getting this animation curve here, which I can then highlight and set to linear, like so. Let's just close this and reset this, toggle real time, and hit play. Now you're seeing a few issues here that I was mentioning. First, this is damn slow. Second, these spheres jitter around. Why is that? What we're doing here is we are distorting this underlying grid, which is running in real time. However, after that, we're scattering points onto this moving grid, which already slows it down a bit because we relax those points. And that also introduces this jitter, because in each frame we're scattering onto slightly different geometry, which totally messes up our point distribution in space. And as an additional factor, we post-relax those points afterwards, which again is slow, as you can see here, as it is cooking each frame, as the underlying geometry and the point distribution is changing, so we need to recook this relax, and also it introduces additional jitter. So what could we do instead? Well, let's get rid of this mountain here, reset this, highlight our grid with the painted density attribute. What I want to do is I want to move the individual points of this grid here along the y-axis. And I can easily create a vector, that is a directional arrow, so to speak, pointing in the y-axis using this grid's normals, because the normals of a geometry always are perpendicular to the geometry's faces. So let's do that by, after this grid here, wiring in a normal sub. Goes in here, and now let's display the normals. And by default, Houdini creates vertex normals. However, as we want to move around points, let's set those to points here, and you can see those blue lines here represent the normal vectors of this geometry's points. Next, we painted this attribute here. I want to just switch off the normal display here. And now we will have our first encounter with scripting. Don't fret, it'll be visual. It will be VOPs, vex operators. And as we're working on points, let's drop down a point VOP, which we're going to wire in after the attrib paint. And a point VOP is something special. It is a subnet into which we can dive in and then customize and build our own small programs. So these nodes up here are pre-compiled programs that side effects designed, developed, and deemed necessary for us to use. However, if we need something custom, we can use a point VOP. Dive in there and find something like a scripting language, just node-based, with which we can build low-level functions. The first thing that I'm seeing here is a bunch of globals, and these are the attributes that Houdini by default imports into this network. So for example, a point position, a point's velocity if it has some, point's color, and point's normal. And here are the default attributes it exports: the point's position, velocity, normal, color, and force. So for now, let's just try something silly and drop down an add, and add together this point's position with its normal, and output the result to the point position. Let's go up one level and highlight this point VOP. And you can see our grid just jumped up by 1 unit. Let's ghost the underlying grid so we can see this is the translation we just did by just adding these normal vectors onto each point's position. However, that's very uniform, so we're just moving this grid up. So instead, before we add the normal to a point's position, let's multiply it with some noise to vary the amplitude with which the points are displaced by dropping down a unified noise. And unified noise is not the fastest node there is in bobs. So for now, to dial in values, I'll use the static node and later switch it out with the normal unified noise when we're building the animation. So drop down the static in here, and this one needs a position to work. So we're going to wire up the position with our points position, and it's going to output a noise, a one-dimensional noise, so just a scalar. And this scalar is what we're going to use to multiply our normal with. So we need a multiply. Normal goes in the first slot, and the noise goes in the second slot. And now we're having this neatly undulating soft noise here. Let's dial this in a bit by setting the fractal type to terrain, setting these octaves to 2, and animating this offset by just typing in here $FF times 0.0, let's say 2. And what this expression is, it means take our current frame number, $FF, and multiply it by 0.02. So you're slowly moving along your y-axis, which doesn't do much because it's a static noise here. So again, if you set up your noise and you are confident with it and happy with it, let's switch it out with a normal unified noise using the same settings. So we're going to set this up to be a terrain of 2 octaves. Having the same offset expression in here, and then again just taking this position, wiring it over here, and taking this, wiring it into output. And you can see this cooked a while. As I mentioned, unified noise isn't the fastest node there is, so let's head up and hit play and see what this does. And not much, apparently, and that is because this expression in here does not get evaluated properly. So let's get rid of this by Shift-Control clicking in here and setting this to 0 again. What I want to do instead is promote this parameter onto our point VOP so that it's available one level above our very low level nodes here that we're setting up. So I'm going to go to the offset here, middle mouse on this, and go to promote parameter, and that's it. I'm going to go up one level again, and I'm seeing here I got this offset. So in here, $FF times 0.02. Now this should evaluate properly. And it does. You can see this slowly undulating noise here. Let's expose the controls for the noise's frequency as well. Again, diving in here, middle mousing on the frequency and going to promote parameter. And this yellow thingy here denotes that we promoted this upwards. Okay, let's go up one level and maybe dial back the frequency to say 0.2 along each axis. And let us hit play again. And that is fine for me now. One thing I'd like to tweak, and again, let's go in there and promote the final amplitude here, which is CC amp, I think. So middle mouse on this, promote the parameter, takes a while to cook, and then let's head up again and dialing in the final amplitude to be 5 along each axis, resulting in this. And again, let's hit play. And after a bit of caching, we are seeing this, which is nice. Why all this hassle, you might be asking? Well, if you remember rightly, we wanted to get rid of all this slow scattering, slow relaxation, and also the jittering it introduces. And the nice thing about the points after they've been relaxed, now that we scattered them onto a grid that has a normal attribute written on it, you can see when we middle mouse on those points, they also do have a normal. So instead of wiring our point VOP with the noise that distorts and moves everything up here, let's wire it in after the point relax and highlight this. Hit play. And you can see we are now getting those undulating points there, which then we wire back into our attrib randomize. Let's just clean up the setup a bit, like so, and highlight the out node. Hit play again, and you can see we now have those slowly, smoothly undulating spheres there. If you guys like what we're doing and want to support us, you might want to head over to our Patreon, and we'd like to thank all of our patrons, especially Refik Anadol, Chris Hebert, Important Looking Pirates, Encore VFX, Patrick Fillion, and Gearbox Studio Quebec. Thanks so much, guys.